All right, so this week we're going to take a look at two sections, 3-1 and 4-1. Each section we'll do over 2 days. Okay, the first section we're going to look at, 3-1, is on what's called inverse trig. All right, so basically, anytime that you do something in math, there's always a way to reverse it. For example, if you add something to a number, what's the opposite of adding? Subtracting. Yep. If you multiply, you can divide. Okay? If you take and square something, you can square root it. Okay? In calculus, if you differentiate, you can integrate. Okay? They're just two things that do the opposite. Well, last week we looked at problems like, say, taking the sine of 30, okay, and you'd write down your answer. Maybe you need to make a sketch, but in the end, you should get an answer of a half. Well, this week, we're going to see how we can take 1/2 and change it back to 30. Okay, so our goal this week, or at least for today, is going to be to find an angle. Okay, we're not going to find the 1/2. That's what we did last week. I'm going to ask you for the angle. Okay, and we can use inverse trig to do that. All right, so first thing is just how do we write it? Okay, there's two ways you can write the word inverse sine. You can do this sine with the -1 up high. Okay, that -1, it looks like it's an exponent, and it's written where you would put an exponent, but it's not an exponent. Okay, it's just, think of it as just the symbol for inverse sine. Okay, some textbooks, especially older textbooks, they write it a little differently. They write arc sine. Okay, arc sine just means inverse sine. It's an older way of writing it. I think our book mentions it, but we're going to stick with this notation. Okay, sine to the -1. Okay, and I'll show you how you do it on your calculator. Okay, inverse cosine has a similar notation. Cosine with a -1 up higher. Again, older books, you might see it written as arc cosine. And inverse tangent, tangent with a -1, or arc tangent. All right, now notice, last week we talked about how many different functions. These were the first 3, but there were a total of 6. Okay, there was sine, cosine, tangent. Then there was also secant, cosecant, and cotangent. Well, the calculators don't have buttons for doing those other 3. The inverse secant, inverse cosecant, inverse cotangent. If we have time, we'll take a look at how to do it. These are the most important ones, though. All right, so how do we type them in? Okay, usually to get to the inverse trig buttons, you have to press second, and this is for scientific calculators as well. And then pick sine, cosine, or tangent. Okay, when you press that, it'll fill in sine to the -1. Okay, so just press second and then sine. Okay, if you want inverse tangent, just press second, tangent. That's it. And then you'd have to type in a number, like inverse tangent of 25. Okay, so the thing that you type in, we call that the argument. 25 is the argument, the thing I'm going to take the inverse tangent of. Okay, so any questions on how I type that in? Okay, at first, we're not going to need the calculator. We're going to use a chart for some of the answers. Okay, so just hang on to that chart. All right, so anytime we do inverse sine, inverse cosine, or inverse tangent, we're always going to get an answer between 2 numbers. Okay, and I'm going to show you, at least for inverse sine, why we get what we get for numbers. Okay. Right, so anytime you do inverse sine, okay, I did inverse tangent a second ago, but if you typed in inverse sine and you type in a number and hit enter, I guarantee you the answer is between -90 and 90. Okay, and that's important. Okay, I'm going to show you why it has to be between -90 and 90. Okay, so this next part I just want you to watch. Okay, the next part I'm going to show you, the next slide. You don't have to write this part down. Just watch what I'm doing. This, you do want to write. Okay, and I'll put it back on. All right, so I've got a table. Okay, and I'm just going to find these values. I've got some different angles, and I'm going to take the sine of that angle and see what I get. Okay, so let's start with the sine of 30, and I got to switch over to degrees. Quit and type it in, and we get 0.5. Okay, again, just watch this part. Okay, I'm going to do the sine of 65. And I get about 0.91. Okay, I'm going to take the sine of 90. And I get 1. Okay, I'm going to hold off on this last one for a second. Okay, so what do you think would happen if I typed in second inverse sine of a half? Not sine, but inverse sine. I'm going back. I get 30 degrees. Okay. What if I type second inverse sine of 0.91? What angle do you think I would get back? Yeah, 65. Or I rounded this, so I might get like 64.9. Okay, or 65.5. Okay, it was rounded. And if I did second inverse sine of 1, and I hit enter, what angle would I get back? 90. Okay, so the whole point of inverse trig is the answer it gives you is an angle. Okay, you're working to figure out an angle. Okay, let's take the sine of 150. Okay, I get 0.5, or 1/2. Does anybody see where that answer where it happened earlier?
30.
It happened at 30. Okay, so the problem is if we were to list, like make a little diagram, okay, and list our answers here, 1/2, 0.91, and 1. Okay, that would get matched up there. That would go there. That would go there. And this one would go here. So usually what you do is you look at the number on the right, you follow the arrow back to the number on the left. What happens if you're at a half and you try to follow the arrow back to the left? How come? What? So if we were at a half and we try to follow the arrow back, what do we have to think about here that doesn't happen with these other two?
Which way to go?
Yeah, which arrow should you follow back? In other words, should you say that the answer is 30, or should you say the answer is 150? There's only one answer. Okay? So we need to come up with a way that everybody agrees what the answer is going to be. Right? So we're going to basically put limits in. What's the highest value? What's the lowest value? And your answer has to be between those. And the easiest way to see what the limits are is to kind of look at a picture. All right, so this is a picture of sine. Okay, it says it up at the top, sine of x. And sine looks like a wave. Okay, and basically the way we can figure out what the answer is we're going to just look at a small section. Okay, let's try to just focus on what's in between these white blocks. Okay, pretend everything else is blocked out. Okay, just going to focus on that section. My goal is to focus on a section so that if I put a line in, the black line and the blue curve only cross one time. If they only cross one time, then I will only get one answer. And what just happened earlier, you won't have a choice of which answer to pick. All right, so if I look at this section, in that area, does the black line and the blue curve only cross once? No, it crosses twice. Okay, so this is not a good section to look at. Okay, let's try looking at a different section. Okay, it's still part of the wave, but yeah, let's focus on that. Now, if I put a line anywhere in that section, does the black line and the blue curve ever cross each other twice?
No.
No. Right? So we're going to focus on this area. Okay, I'll bring it back up. So we're focusing from here to here. Each one of these marks on the page is 90 degrees. The origin is 0. So what would this first mark be at? 90. And how about to the left of the origin? Negative 90. So if we look between negative 90 and 90, what I'm saying is we're guaranteed to only get one answer. Okay, you're not going to get multiple answers. That's why for inverse sine, if you want to think about it visually, we're always between negative 90 and 90. If you weren't, you would get more than one answer, and we don't want that. Right? Let's look at inverse cosine. Okay. Does anybody know what the graph of cosine looks like? Okay, it looks pretty much the same. Easiest way is to show you both at once. Okay, here's sine. And let's graph, I'll fix that, and cosine. So there's cosine. Okay, does anybody see the difference? Yeah, if you kind of look at the origin for one example, okay? In cosine, it doesn't go through the origin. In sine, it does. Okay, but they're pretty much the same wave. They each have the same highest point, the same lowest point. But it's like it's a little bit off. Okay? All right. So let's try the same trick we did. Let's try looking at negative 90 to 90 and see if that works. Okay, for cosine, there's negative 90 to 90. Does this black line only cross the blue curve one time? No. Then what's going to happen is if we look negative 90 to 90, we're going to get two answers because it crosses twice. We don't want two answers. We only want one. Okay, so let's try sliding it about right there. Okay, does that black line and blue curve cross more than once now? Nope. Now it's good. Okay. Does anybody know what we are between? If we focus from here to here. Yeah, that's 0 to 180. Okay, so if we all agree to focus on that one section, you will always get one answer per problem. You'll never get multiple answers. Okay, and up above, I've written it in degrees, and down below, it's in radians, 0 to pi. Okay, an inverse tangent. If we have time at the end, we can look at the graph, but that one, it's not a wave. It's a very different graph. And that one also has to be between negative 90 and 90. But there's a difference between the negative 90 and 90 for inverse tangent and for inverse sine. Anybody see the difference? Yeah, Cass.
Sine can be equal to 90 or greater than, and then tangent can.
Right. With sine, it can actually equal the 90 or the negative 90. With inverse tangent, it cannot. And in a minute, we'll look it up on our table. If you look in the tangent column and you look at 90, you'll see something interesting written in the table. Okay, so it cannot equal 90. Okay, does everybody have these three things written down?
Nope. That's only Billy Rubin.
All right, so now's the part, if you're stopped writing with that last thing I showed you, you want to start writing again. All right, so inverse trig, it's exactly the opposite of what we did last week. Okay, does everybody have this so I can make it bigger?
Yeah.
Okay. These were the kind of problems I gave you last week. I gave you an angle. Somebody pick an angle that's a multiple of 30 or 45? 30? Sure, use 30. Okay, so I gave you an angle, and I gave you a trig function. Somebody pick one of the 6 trig functions. Cosine. And I said find the cosine of 30. Okay, and you draw whatever you have to do to look that up. Draw your diagram, make your unit circle. Cosine is the x value. And this would be the answer that I was looking for on the test. Okay, that's what we did last week. I gave you an angle, gave you a trig function. You gave me what I just circled. Okay, with inverse trig, now we're reversing it. I'm going to give you the root 3 over 2. Okay, and I'm going to ask you what the inverse cosine of root 3 over 2 is. And the answer that you get, or what you need to find, is the angle. So this week you're going to give me the angle. So based on what I just did, anyone think they can tell me inverse cosine of root 3 over 2? It's 30 degrees. Yeah. And that's the answer that I'm looking for this week. Okay, so they're exactly the opposite question. Okay, any questions about how what I'm asking this week is different from last week? Okay, with inverse trig, you are always giving me an angle. So your answers have 2 different units they could be, degrees or radians. All right, 2 ways we can do inverse trig. If you have an angle that's a multiple of 30 or 45, okay, we use the table. Okay, we're going to use that table I just passed out. Now, the problem is, how are you going to know if the answer is a multiple of 30 or 45? Okay, that's the question I'm asking you. You're not going to know the answer before you do the problem. Okay, so you might have I'm just going to show you an example, and I'll come back to this. Okay, you might have a question like this. What's the inverse cosine of -1/2? Well, I told you that you can use this table if the answer to this problem comes out to a multiple of 30 or 45. But again, how do you know the answer to it? You haven't done the problem. You look at the argument. Okay? The arguments are all the things that you see in the table. Okay? This table has arguments that are numbers like 0. You'll find zeros in here. You'll find ones, negative ones, a half. You'll find some square root 3 over 2s, some square root 3 over 3s. You'll find square root of 2. Okay, those are the kinds of arguments you're going to see. There aren't really that many different numbers in these tables. Okay, there's a lot of, just if you look at root 2 over 2, okay, there's a lot of root 2 over 2s, okay, if you look through the table. So if this number, okay, that's the argument, is something that looks like one of these, then you're going to try to use the table. I mean, the worst thing that can happen is you try to find it in the table and you don't find it, and then you just use your calculator. All right, but when we see arguments like this, square root 3, square root 2s, think table. Okay, I'm going to look it up in the table. Okay, if you can't find it in the table, I'll show you after how we use the calculator. Okay, so any questions what you're going to try to look for in order to use the table? Looking for these kinds of arguments. Okay, does everybody have that? All right, so next we'll start with sine, and then we'll go through how you use the table. And if there's multiple answers, we have to remember what sign is supposed to be between. Okay, so we'll go through that. All right, so the first one I want is that inverse sine of 1. Okay, 1 is called my argument. It's the thing I'm going to take the inverse sine of. So now, what I'm going to do, on my table, I'm going to look in the sine column, and I'm going to go down the sine column till I find a 1. Wherever I find a 1, I go across to the angle, and that's my answer. Okay, so we're finding inverse sine of 1. Okay, looking at my table, anybody think they can tell me what the inverse sine of 1 is? Yep, 90 degrees. Or what if they wanted it in radians? Pi over 2. Both are listed right in the table. And both of them are listed as negatives as well. Okay. With inverse sine, what does your answer have to be between? Negative 90 and 90. So really here, you guys had two choices. You had 90 as a choice, and you had negative 270 as a choice. Only one of those is between negative 90 and 90. So you pick the one that is. Any questions on that? And that's it. That's the answer, 90 degrees. Okay, on the test, I will ask you for a specific unit. I'll either say do it in degrees or do it in radians. Okay, on the homework, I don't think it says how to do it. So you can pick either one. Just make sure you know how to find both. Okay, next one is inverse sine of negative 1. Okay, inverse sine of negative 1. Okay, where's the first time you see that? What angle? Okay, 270, which somebody said is the same as negative 90. And I think that's it. Yeah. So now we have a choice. Which one of those answers should I write? Negative 90. Okay. The answer has to be between negative 90 and 90. So that we all agree, we pick the negative 90. Okay, any questions on that? All right, let's try inverse sine of a half. Okay, inverse sine of a half. Okay, Taryn, what's the first angle that you see? Look in this column for sine and look for a half. And what angle is it across from?
30.
Yeah, so we have a choice of 30 or negative 330. We'll figure out which one in a second. Does anybody see where 1/2 occurs again? 150. Okay, this is the second answer. Okay, this is like the problem when I drew the horizontal line and it hit the curve twice. Here's the second time it's hitting. Okay. Now, we already decided we're going to be between what two numbers?
90.
We're going to be between negative 90 and 90. So out of these four things I just circled, only one of them is correct. Which one? 30. 30 is the only one between negative 90 and 90. Okay, what if they asked for radians? What's 30 degrees in radians? Pi over 6. Okay. Okay, any questions on that one? All right, let's try inverse sine root 2 over 2. Again, I'm giving you all arguments you can find in the table. Okay, so these are all things you want to look in your table. Okay, so first I want to see if somebody can tell me all four places where it occurs. And then once we know all four, tell me which one is correct. Anybody tell me one of, yep?
Could I have a table, please? I never caught one. I was wondering what you guys were talking about all this time.
Anybody else need a table?
That's a ring.
so we're looking for root 2 over 2. Okay. Anybody see what angle is across from root 2 over 2? Okay, 45. Or we could write negative 315. We'll figure it out. And where else?
135.
Yep. Okay, so this one is like the second time that the line would be hitting the curve. Okay, out of the 4 things I circled, which one is correct? 45. Good. Or pi over 4 if you wanted it in radians. All right, let's try one more for sine. Inverse sine of negative root 3 over 2. Okay, make sure you look for the negative too. Okay, because there's going to be a positive root 3 over 2, but that's not what I want here. Okay, this time, let's just see if we can get the correct answer. We don't have to circle all 4.
Oh, I know this.
Okay, anybody think they figured out the inverse sine of negative root 3 over 2? 60 would be if it was positive. But yeah, since it's negative, we look at the negative 60. How come I don't write 300? It's too big. It's got to be between negative 90 and 90. So you can't write it as 300. Okay. Right, so any question on using the table for inverse sine? If you're still having trouble, we're going to try a couple with inverse cosine, and we'll try a couple with inverse tangent. Okay. We're just going to look at a different column. That's the only difference.
I'm just confused on how to read this thing. Like, what are you even talking about?
All right, let's try a couple more with inverse cosine.
I was just confused where you get the numbers from.
Think of n for this one.
All right, so inverse cosine of 0. Okay, the way you're going to do it, we're dealing with inverse cosine.
So it's on cosine.
Go to the cosine column.
Okay.
Keep going down until you find a 0.
Oh, I found one.
Okay? And then you go across to the angle,
So it's 90,
and that's your answer.
and that's it?
Yeah,
Okay, then I understand it. Thank you.
you're welcome. Now, I want to be careful here because what do I have to be between now? I'm not negative 90 to 90 anymore. What's inverse cosine?
0 to 180.
0 to 180. Okay, that's important. Keep that in mind. Any question on inverse cosine of 0? Okay, biggest mistake I see when people use the table, they accidentally look in the wrong column. Okay, so just make sure you're in, maybe if you want to color code it or highlight or something, but make sure you're in the right column.
I have this one.
Okay, how about inverse cosine of negative 1/2? Okay, inverse cosine of negative 1/2. Yep, you see it in 2 spots. Okay, negative 1/2 is across from the 240, and it's also across from 120. Which one is correct? 120. Okay. Somebody might be like, oh, wait, I thought he said negative 90 to 90. 0 to 180 now. Okay, inverse cosine can go up to 180. We say 120. Thank you. Or if you're doing it in degrees, 2 pi over 3. Radians, sorry, 2 pi over 3. Okay, how about inverse cosine negative root 2 over 2? All right, I heard negative, somebody say negative 135. Yeah, that is a choice. What else is a choice? 135. Okay, which choice is correct this time? 135. Does everybody see why I'm not going to write negative 135 or 225? Yeah, not between 0 and 180. Okay, any question on inverse cosine? All right, so we'll try a couple with inverse tangent. Now, what did we say for inverse tangent? We have to be between? Right, negative 90 to 90, but we can't equal negative 90 or 90. What do you notice if you look in the tangent column? What happens at 90? It's undefined. Okay, undefined. How about if you look in the tangent column at negative 90? It's also undefined. Okay, so that's why earlier I wrote it cannot equal negative 90 or positive 90. It's undefined. Okay, what's inverse tangent of root 3, square root 3? Yep. See it at 60. I'm probably going to see it again later on, but I don't even need to look because I already found the answer that's between negative 90 and 90. So once you find one answer, you don't have to look for a second one. There isn't going to be one. Okay? So the answer is just 60. And how about inverse tangent of negative root 3 over 3? Let's see. Negative, which one?
I was looking at cotangent number.
Oh, yeah, you're looking at cotangent. Yep, I can see that. This one's across from the last row, but which one of those do we want to pick? Negative 30. Okay, negative 30. Right, so any questions on the table? Either in degrees or radians. Right, so it's pretty straightforward to use. Just make sure you look at the right column and look at the right row. Right, so this table only has on it angles that are multiples of 30 and 45. If you can't find your answer in the table, then we use our calculator. All right, 0.65. Okay. Is that a number that we ever saw in the table? No. If you look down the sign column, you're not going to find 0.65. Okay? Because you're not going to find it in the table, we use our calculator. I'll do this one two ways, and I'll show you a mistake people make on the test a lot. Okay. All right, so press second sine. If your calculator is different and you need help figuring out where inverse sine is, I can try to help you. But if you really can't figure it out, you can just use one of mine. All right, so second inverse sine, 0.65. Okay, so if I'm doing it in degrees, I get 40.54. Okay, if I want to do it in radians, I don't change anything I type in. What's the only thing I have to change? Yeah, just change the mode. Okay, type exactly the same thing in again. Okay, in radians, it's about 0.771. Right, now here's the mistake that people make on the test. Say I gave you three choices here. 0.65, 40.54, or 0.71. There's only one answer there that is correct. There's not two correct answers up there. Which answer is correct? B. What? Why not C?
Because the radian is not produced.
Yeah. The answer is 0.71 radians, not 0.71 degrees. Okay? So the way I've listed the problem right now, the correct answer is B. Okay? Now, what if I do that?
Maybe C.
Now the correct answer is C. Okay, they're all in radians. So if you have a multiple choice question, which you will, make sure you look at the units. Okay? If you see the little circles, put your calculator in degrees. If you don't, put it in radians. All right, let's try this one. Inverse cosine of negative 0.24. Okay, inverse cosine of negative 0.24. Okay, I'm going to do it in radians first because I'm already in radians. Okay, did anybody try it in radians? And see what they get. You tried, Jamie, did you get an answer? You did it in degrees? What did you get?
76.1.
76.1. Okay, let me check.
I got 132.
So you see what happened? Okay. Yeah, it's 103.89. Okay, and if you did it in radians, just change it back. Now, if I didn't want to change the mode, I could convert that by hand. Could just multiply by pi and divide by 180. Okay, might be faster on your calculator to do it that way than to go in, change the mode, and keep changing it back. It's up to you. Okay, in radians, you should get 1.81. 1.81. Okay, any questions on that one? Right, and we'll try one more. Okay, inverse tangent of 34.3. Just going to do this one as a degree. All right, so inverse tangent, what did I write? 34.3. Okay, 88.33 degrees. Okay, any question on that last one? All right, for a minute, I want to forget about inverse tangent. Okay, I want to go back at the table and just look at the sine and the cosine columns. Okay, if we focus just on those two columns, what's the highest number that you see in either the sine column or the cosine column? And I'll give you a hint. These numbers are less than 1. Like square root 2 over 2, that's 0.7. Square root 3 over 2 is 0.86. So what's the highest number in those columns? 1. Yeah. And what about the smallest, the lowest number? 0? Do we have any negatives?
Yeah.
So yeah, we go lower than 0 then. Yeah, the lowest number you'll see in any of those columns for cosine is -1, and for sine is also -1. Right. Now let's take a look at this picture again. If you look at that graph, what does it look like the highest it ever goes is? Yeah. Okay. When you're looking at it vertically, each tick mark is 1 unit. So the highest is 1. How about the lowest? -1. Okay, so this graph is always between 1 and -1, which means any number that you plug into inverse sine or inverse cosine has to be between 1 and -1. Let's try one that isn't. Somebody give me a number that's not between 1 and -1. 2. Right, let's try typing it in and see what happens. Second, inverse sine of 2. Okay, it says error. Okay, it says it can't do it. And the reason it can't do it is because you're asking this question. You're asking, where do the blue line and the red line cross? Okay, where do they cross? They don't. Okay, that's why it can't do it. Okay? The only way that this line is ever going to cross this curve is if you pick a number between -1 and 1. Okay? Same thing happens for inverse cosine. Now, look at inverse tangent. Okay, where was it? Right here. Is that number between -1 and 1? No. So because it's not, and it did work, okay, we got an answer, that means tangent goes above 1. Okay, in fact, it at least goes up to 34. Okay, let's look at that graph. Anybody seen the graph of tangent before? Okay, there's a pattern to it, but it's not a connected wave. Okay, we get these kind of curves. Okay, and there's a lot of them. Okay, so just focus on the middle one. Okay, ignore all the others. Right now, you're looking at it from +4 to -4. Does it look like the graph is stopping? No. In fact, if we go from, let's go 50 to -50. 50 to -50. Again, just focus on the middle section. Let's do zoom. That doesn't quite look right. Let's try -40 to 40. Hopefully the calculator will cooperate. All right, so it looks like the graph is stopping, okay? Which is one reason why we have to be careful when we use a graphing calculator, because it should not stop. So let me try graphing it on here. Okay, so there's our graph we had before. Yeah, it's a little slower. Okay, let me try -40 to 40 on this one. Okay, -40 to 40. That's how it should look. I'm not sure why that other one is doing something strange. But my point is now, does it look like it's stopping at 40? No. It's just going to keep going up forever. So when you do inverse tangent, I don't care how high of a number you pick, there'll always be a way that a line crosses it. Okay? Tangent is not trapped between 1 and -1. Tangent goes up forever, and it goes down forever. So that's a disadvantage of using a graphing calculator. You've got to be careful, because sometimes the picture that you get is not what you should get. This is what you should get on the left. I don't know what's happening. Well, actually, my only guess is one way I'm doing it in radians, one I'm in degrees. That shouldn't matter, but sometimes the graphing calculator has trouble with degrees. I bet that's probably it. It's just a computer thing. Right, so any questions on that? All right, so now we looked at how to do inverse trig using this chart. Okay, explained what inverse trig meant, and how to do it on the calculator. Okay, so tonight's homework will have a little bit of both. Okay, so the homework, it's on 187. Okay, I'd like you to try 13 to 17, 19, 20, 22 to 31 all, and 33. Okay, we'll take a look at that tomorrow. We'll finish up 3.1 tomorrow, and then we'll also start the first half of 4.1.